Digital identity is already part of our daily lives. Opening electronic locks, making a phone call, paying with debit or credit cards, using paperless tickets for public transport, or even crossing country borders all rely on some digital attributes transmitted in the background. In our research, we build a solid foundation for digital authentication in the physical world. We focus primarily on strong privacy guarantees while enabling all these digital attributes to follow and enable our actions in the physical world. Just like a digital shadow that belongs only to ourselves and that we can fully control. This is the main goal of our Christian Doppler research laboratory named Digidow. Let's have a closer look at one particular use case, attendance tracking. This can be used for many applications like time tracking for workers, marking class attendance for students, or keeping track of physical proximity for pandemic control. How can such a system be as privacy positive as possible? A core aspect is that the user should be in charge of deciding if they want to participate at all, and if so, who is receiving their encrypted data. Thus, individuals need to be able to opt into authenticating themselves to various parties via sensors in the environment, such as our sensor in the printer room to track possible COVID infections through face recognition. No user interaction at all is required. This explicit opt-in step provides user transparency and control. An enrollment process sets up a so-called personal identity agent, which we also call PIA, and enables verification towards specific parties. In this example, this is a camera sensor network and location-specific attendance lists used for COVID-19 contact tracing at the workplace. A core aspect of the Digidow project is decentralization. We plan to avoid single points of failure and control, which can be disastrous when data leaks occur, and which would be ideal targets for censorship and other attacks. One intuitive option to enroll with a new system is scanning a QR code, which helps setting up the initial connection between the individual's PIA, sensors in that particular environment, and third parties interested in some of their digital attributes. We call these parties verifiers. Let's see what happens when an employee enters a room where a Digidow sensor is placed. We now have information flowing from the sensor to the PIA and from the PIA to the verifier. For COVID-19 contact tracing as a specific example, when individuals enter common areas such as the department printer room, their PIA can register the place and duration with an attendance list. In our simple example at a single workplace, PIAs of employees can easily be configured to know all the available sensors and verifiers they interact with. How the PIA and sensor can best discover each other while preserving privacy is something that we are actively researching under the term network discovery. While individuals have a right to privacy, sensors like cameras in the environment do not. Among other sub-projects, we therefore work on a sensor register where all such sensors and their properties would be available for PIAs to locate them. It is also important to consider how Digidow interacts with an individual who does not want to participate in this system. An individual who has not explicitly opted in should not trigger any network communication at all. That is, as long as they don't have an opted-in lookalike that could plausibly be in the same location. However, even if individuals don't have an own PIA or are not opted into a particular verifier, it should be possible for non-participating members of the public to verify that these devices are working correctly, which includes not performing any actions not in the interest of this individual. How to achieve this public verifiability is another area of current and active research. We aim to build systems that are as transparent about what they do in our physical space as possible, and to prevent even designers and makers of those systems from breaking these security and privacy guarantees. Thank you for watching our demo video. We hope that it was helpful as a first summary of our concepts and the open problems we are currently working on. Please get in touch with us if you want to know more or are interested in collaborating.